I'm Ian Somerville, and I want to continue my series of videos by talking in this video about software reuse and what I call the reuse landscape. The number of different ways it's possible to reuse software and software designs. Software reuse really came to the fore about 15 to 20 years ago, where we saw quite a radical shift in the development of business and enterprise systems, where there was a move away from developing software from scratch, built according to a specific specification, towards reusing existing software, either in the form of entire application systems or as large-scale components that could be assembled into systems. And since then, reuse has become the dominant approach for developing many kinds of software, both software products and enterprise systems. It's less widely used for real-time systems because of the close interactions with the hardware, but even in that domain, we are seeing an increasing amount of software reuse. Reuse is often thought of as a component-based notion, where we have components and we reuse these components in different systems. We assemble them in different ways. But in fact, there's many different ways in which we can reuse software. And I call this the reuse landscape. The reuse landscape identifies the fact that reuse is possible from all sorts of levels, from entire application systems to individual functions. It's possible to reuse domain knowledge by generating software, and it's possible to reuse ideas in the form of patterns, so that we can take these ideas and instantiate them in different ways in different systems. And what I want to do in this video is to just go through this reuse landscape and to talk about each of the possibilities. In the book, I don't cover all of these possibilities. I focus on what I think are the most important and what I've shaded in this diagram. Let's just start with applications and application frameworks. Application frameworks are basically a structure, a set of reusable components associated with a particular type of application that we can use to develop these applications. The most commonly used and the best known being web application frameworks, which are now almost universally used in the development of web-based systems. Examples of these would be Ruby on Rails, where Ruby is the programming language, Rails is the application framework. We can create new systems within an organization by integrating existing systems which are there. So it's application system integration. Or we can start with specific application systems that have a particular purpose, such as, say, an appointment system for a medical practice, and we can configure that for use in a specific area. It's possible to take a systems of systems approach to reuse, where we build systems by integrating systems which don't just belong to the same enterprise or to the same owner, but which are integrated across enterprises, distributed systems integration. Or we can take another form of application system reuse, which is ERP system reuse. ERP systems are collections of modules which support business activities such as manufacturing, and collections of process information where we link processes with the data that's used within these processes, and we build up a whole business model using the ERP system. Examples of ERP systems are produced by companies such as Oracle or SAP. Continuing the idea of systems, one form of reuse is to take a legacy system which may not have been designed to be integrated with other systems or to be reused, and to build interfaces to that, such as a service interface that allows the facilities of that legacy system to be accessed, and so it can be integrated and reused with other systems. And then there's the approach of software product lines. Software product lines are another approach to system reuse. And this is a situation where we have a generic system that has a core of reusable functionality, and around that we build more specific functionality for particular customers. So all of the members of the software product line have a common architecture and many common components, but the source code is changed to make them suitable for a customer's needs. At the component level, we can have component-based software engineering, where standard reusable components are developed that can be included in different systems. And of course, these may be represented or instantiated in different ways. They can be developed as components, as I have explained in chapter 16 of the book, but they can also be represented as program libraries, collections of functions, say that handle system graphics, or they can be represented as services, remote components that can be invoked as required. A more abstract form of reuse comes from program generators, where we embed domain knowledge in a system and then write some domain-specific description of the facilities that we need, and a program is generated from this domain knowledge to provide these facilities. We can see this approach also in model-driven engineering, where it's possible to generate quite a lot of code from a model of the system that has been developed. Another form of reuse which links both component-based development and program generation is called aspect-oriented software engineering, where we define components as aspects and we weave these into the program in different places. This was an approach that had looked as if it had a great deal of promise, but unfortunately that promise has not yet been realised. And patterns of different kinds are effective ways of reuse. At the lower level, we see design patterns, which are commonly used approaches to particular design problems. At a higher level, we have architectural patterns, where we understand the strengths and weaknesses of particular architectures and can choose the appropriate architecture for the application we're building. It's very important to understand that there's no best approach to reuse. Each of these approaches have got strengths and weaknesses, and each can be used in different situations. The approach which you might choose depends on the software which you have available, the skills of the people, and the culture of the organisation which is reusing the system. Key factors that have to be taken into account when choosing an approach to reuse include the development schedule, the expected lifetime of the software, the team developing the software and their skills and personalities, how critical is the software and whether or not there needs to be a regulatory case built around that software, the application domain, and the software execution platform, the computer and operating system on which the software will run. In summary then, software reuse is the most cost-effective way of developing software. Without doubt, it's how you should always start in a software engineering project. And what we've seen in this video is that there's a whole range of different ways in which software can be reused, and you should choose the one that's most appropriate for the software project in which you're engaged.